Hi, everyone. So this talk is about how we did Lambda functions at FundApps. I'm actually about to leave FundApps and join a new company called Depop, but this is kind of my last thing for FundApps, so that's pretty cool. FundApps is a financial services company. So what we do is handle a large amount of positions and financially held data for banks and hedge funds, pension funds. About $3.5 trillion per day of transactions that we look at. It's sort of day plus one, so we look at people's transactions from the previous day. So it's not sort of or second by second sort of stuff. So this talk is kind of about serverless, and about a year and a half ago, FundApps wasn't doing any serverless at all. I joined with some serverless experience, and I was writing Go when I was at BBC, and they weren't doing any Go either. And the idea is kind of similar to the previous talk. FundApps was a C# monolithic application running on Windows. And I kind of came in and sort of said, let's run Go on Linux. And they were like, cool. So we structured it in kind of a sort of like a service-oriented architecture in the beginning. We didn't go like full microservices. So it's kind of like this break this bit out and this bit out and just work it over time. And I sort of said, let's do that. And over the few months that I was there in the beginning, it was kind of like, cool, we built up this really nice business logic layer, some really great packages in Go. And then we had this really great use case, and we thought, well, we could try Lambda. Lambda is Amazon's functions service. And the basic use case was importing data from other financial services that provide data. So financial services are kind of stuck in the past, so the first one we did was FTPing data. So it's kind of crap, but it was okay. We built a lot of packages in Go that were kind of specific to Amazon services, so storing data in S3, using RDS, DynamoDB, and we thought this would be okay to do, and we didn't think that going down the C# route was actually something we had to do. So the data we use only changes once a day. It's exchange level limits. So if you were trading pork futures, for example, on the Chicago Mercantile Exchange, how much can you buy today, right now, might be different to yesterday and the day before. So it's kind of simple data, but important for companies to know. And they will base their trades on those figures and how much they already own and how much they would like to buy. So as you can imagine, it's a two-part process, importing and processing the data. So we want to store the raw data, and that's kind of one part of the Lambda, one Lambda, and then we want to process the data later. The reason we want to do that is because the schema will change over time, and the way we want to present the data will change over time. So we want to store the data raw, and then potentially reprocess it at a later date. And we sort of looked at what approach we could take. So obviously, at the time, this is sort of 14, 15 months ago, most people doing functions as a service were using JavaScript. So Google, Microsoft with Azure, and Amazon with AWS. And so we looked at like what was our kind of core requirements for this. And that's why we sort of looked at Go as kind of continuing on our journey. So we'd had a lot of really great success with Go. And we wanted a strongly typed language. As you can imagine, like we're in a bank right now. So we didn't want any like weird type conversions or any kind of rounding. When you're dealing with $3.5 trillion worth of assets, it's probably not a good thing. And I'd had some previous experience running Go on Lambda. When I was at BBC, I wrote like this a few years ago, which was basically sending Slack messages from Go. It was kind of a hack. Basic debugging, used a makefile for deployment, heavy use of AWS console, not really suitable for an entire team of developers either, but it worked, which was great. And when we look at other tools like JavaScript, such as the serverless framework, which is a JavaScript-based framework running on Node, it's really popular, and definitely should have a look at it if you're going to do anything to do with Lambda. They had a lot of great benefits. Like, it was really fast to deploy. It was really easy to deploy stuff. Like, you could write like 5 lines of code and just deploy a function. It was great. And it was always like consistent when deploying. And like that was something that we absolutely had to be as a financial services company. So if you're going to deploy an unsupported language onto a platform, you've got to be pretty confident that it's going to work. Otherwise, like, people are going to look at you saying, what are you doing? So the kind of core requirements: can we add new code, update configuration, package everything, and handle versioning. So it was like, is there a tool that could do this, or do we have to write our own? We also wanted something for the entire team. So not something that was just an ops tool, or not something that was just a dev tool, something that worked for everybody. And it had to play nice with CMA. So we don't want deployments from laptops. We found 2 tools, one called Gordon and one called Apex. And we went with Apex. It's written in Go, which was also a cool thing. So Apex lets you build, deploy, and manage AWS Lambda functions with ease. So that's exactly what we wanted. So it comes with barriers included, supports multiple environments, which is great, exactly what we wanted, and it supported Go, which is great. Some of the features: generates the zip file for you, which is what your code lives in. So it will compile the binary, put it in a zip file, and then upload it to the Amazon service. You can ignore files, which is great for, obviously, if you're actually building and compiling files, you may have a lot of files you don't want in your directory. And you can roll back functions straight from the command line. The ops part of this was what Apex kind of delivered for us, and that was kind of the important bit, that we had this kind of full workflows kind of sorted, that there wasn't any issues with like, oh, well, we have to do this via the console. Like Apex was our one entry point into Lambda. So it's a command line driven tool. It has a lot of options, a lot of features. I recommend you have a look at it. And this is kind of the structure of what you would have with a function. So Apex supports all the languages that Lambda does and Go. So you have your hello function, and in that you'd have a single file called index.js, and in there you would have a handler. The project JSON is just that. So it just handles the Amazon-specific things like the credentials and the name of the project. If you want to go down to the function level, when you want to have very granular functions, you can have a function.json, and that's at the function level. So it'd be under hello there. So this is quite nice because we can have hundreds of functions in one directory, and we can deploy one or many functions at a time, which is great. So kind of this is how you deploy. It's just pretty simple. Just deploy your functions. But you can be really specific about how you deploy your functions. Hopefully it'll look okay. Deploying is straightforward. You can see here I've actually specified a region, so EU West. And this is going to deploy all the functions I have in my directory. And then, yeah, you can see it will step you through each of the things it's doing, and then it will finish, which is great. So what just happened there was it created a zip file with the binary in, uploaded it to the Amazon service, added configuration, updated the environment variables if you asked it to. The important thing for us at FundApps was that we didn't have to deal with a framework that was kind of all-encompassing. So the serverless framework, which I mentioned earlier, and the other frameworks, they generate all the infrastructure for you, and that's kind of a problem with financial services for us anyway. Our customers sort of ask us, what tools are you using, down to like what versions sometimes of what tool. And we can't exactly say we know exactly what we're doing, except we have this framework that generates a load of CloudFormation for us and could do anything because it has our root credentials. That's kind of not ideal. So we wanted to go and use a tool that allowed us to separate the infrastructure from the deployment tool, and that's what Apex gave us, basically. So that's kind of reason one of why we picked it. And at FundApps, everything is created in Terraform. If you've never seen Terraform before, this is what it looks like. It's infrastructure as code, basically. And we wanted this to be completely separate from Apex. And it works quite well for doing that. The second reason why we chose Apex, actually, was the library support that they offer for the Lambda-specific invocations. So if you think of, there are many things that can trigger a Lambda function. Apex have a whole series of libraries written in Go that allow you to handle that. This is a handler. This is a generic handler. And this will take in a raw JSON message, and then you call into your library. In this case, it's a FTP service. We do our work, and then we return an error or a response. And this is kind of the generic handler, which is great. So how does all that kind of work under the hood? Like, there's a Node.js shim that sits on top of your Go binary. It has some quirks. You can't use standard out. You have to use standard error. Standard out is reserved for the shim. And this can have a kind of a bit of a problem if you're using a library that kind of takes over standard out and you have no way of setting that. If you want to use like the standard library logger, you can just set to standard out, so it's the output to standard error. The shim will break if you try and do anything that isn't in standard error, and it will just completely exit the function. This is an S3 handler, and the cool part here is that the function, the handle func, comes with this message argument, and that just handles all of the properties that you're expecting to be a part of the S3 event. So you don't have to like figure all that stuff out, like what's in an S3 payload or a CloudWatch payload or DynamoDB. It just comes with it as part of this library. So it worked out really well for us to use this, saved us a lot of time. Debugging is pretty hard, like in Lambda functions in general. You do a lot of console logging if you're doing JavaScript, but in Go, you have the same sort of issues. Sort of the way we did it initially is we just wrote everything as a library or a package, and then we would write just a single main.go file and then call into those packages. So we would add the handler func for the Apex right at the end, so you wouldn't have any of the potential issues using the handler func in the beginning. That worked quite well. We looked at the Lambda function as kind of like just an interface to our packages. So we would try and not do anything that you couldn't swap out the handler for, HTTP handler or some kind of polling thing. It worked quite well for us. Yeah, and we just read in a sample JSON file that contained the event data that you would get from Lambda, and it worked really well for us. So there are some limitations by using this shim, because ultimately this is what's going on behind the scenes. So main is your compiled binary, and then this what happens inside. So the handle function here that is in JavaScript is being called every time by Amazon. If you think of how a Lambda function works, what happens is it runs, and it essentially caches that in like a container, sort of container. And when you run it again, it will call the handle func again, which is great because it means that you're not loading like all the code every time. The problem is that your Go binary is being executed before that happens. So Amazon do some weird stuff when they call the handle func from within here. So if you were using, say, Amazon's distributed tracing service called X-Ray, and you were to try and get a trace ID from that, you couldn't get access to it because the trace ID is only generated when the handle was called, not when your binary is executed. So there's kind of a scoping thing there because the environment variables are actually overridden by Amazon when they call the handle func. It's kind of a really weird way they do it, but I guess it makes sense for caching. So you're gonna have limitations there if you're using, like we found this, so we can't use the tracing technology in our Lambda functions, which is a shame. So Apex, we wanted the consistently deploy. So we wanted a nice CI pipeline. This is how we deploy. So everything's in GitHub. We then use TeamCity to build. We use Apex on CI. Console we use for configuration, which is pulled in at build time. We want a single point of truth for all of our configuration, which is console. And that's why we don't deploy from laptop, because it comes from console. We then deploy to 2 AWS accounts, dev and prod. And that's good for debugging. We use Sentry for our exception handling, CloudWatch metrics, which we have the Grafana dashboard, which sits in front of it for making it really pretty. And then we use another Lambda function to get all our logs out of CloudWatch and into Sumo Logic, because Sumo Logic's pretty cool for using that sort of thing. This works quite well. We just sort of what's going on behind the scenes on TeamCity, we actually use IAM roles to do deployments. So Apex supports that. So if you want to scope your deployment to very specific things in your CI, you can do that. So performance is obviously important, making sure that it's not any slower than using JavaScript or Python. So this is kind of, to be honest, like this is going to be like sort of anecdotal because like I can't tell you like if you're running 10,000 functions, like what the performance is going to be like versus running 50. So because Amazon will help you out there. So this is kind of just an example of like how quick the initial performance is. So the slow part is because when you first run your function, it'll be slower because Amazon haven't cached it for you. So then it'll get sort of more consistent. This is just doing a simple KMS decryption. So it's calling out to a third-party service. And that will be done every time. And then this one is just handling an S3 event. So it's just doing some work in the background. Again, pretty fast performance. So most of the time you're going to be charged the minimal amount, 100 milliseconds. These are the competing frameworks. As I said, serverless framework is great. Like, you should definitely try it before you start going and putting Go inside Lambda functions, because you have to be really confident that it's going to work for you. I would say it works really well, but most people are just going to go with the most popular one, which is serverless. Gordon as well is a Python-based one, so it's like Go, JavaScript, and Python. So pick whichever one is best for you, I guess. And that's about it for me. Thank you very much. I should just say, so my new company, Depop, that I'm starting at in a week's time. I'm going to start recruiting for them already. So, Depop, and they should read this because I need to learn this. Community-focused marketplace where you can buy and sell streetwear, vintage fashion. We are hiring. Yeah. So, work at depop.com.